Ever wondered how services like Netflix and Amazon know exactly what you want to buy or watch next? It's not magic, it's unsupervised learning. To understand unsupervised learning, let's look at its opposite, supervised learning. Supervised learning requires an answer key to train. If you want to identify cats, you show the AI pictures labeled cat or not cat. But in unsupervised learning, we give the AI raw, unlabeled data and say, figure it out yourself. There is no answer key. We just tell the machine to find the inherent structure and hidden patterns in the data. This is the foundation for finding hidden tribes of customers, detecting anomalies, and much more. Unsupervised learning is all about finding patterns when you don't know what you are looking for. Stay tuned because next we are breaking down the three main approaches unsupervised learning uses to achieve this. Unsupervised learning uses three primary techniques to find structure in raw data. Let's cover them quickly. First, clustering. This is the most popular. Clustering is about finding groups of similar data points. Imagine you are running a clothing store. You feed in purchase data, and the machine automatically sorts your customers into distinct tribes, like trend followers and the value shoppers. It finds the groups without you having to define them first. For analogy, it's like sorting people into distinct tribes based only on their purchase behavior. Second, association with the relationships. This is about finding hidden relationships. The classic example is market basket analysis. Discovering that 70% of people who buy product X also buy product Y. It finds rules that dictate item dependencies. Third, dimensionality reduction. Imagine a huge spreadsheet with 50 columns. This technique is about simplifying the data, reducing it to the five most important columns without losing the critical information. It turns a blurry, overwhelming map into a clear, simple highway map. These three tools allow the AI to make sense of chaos, and of these, clustering is the real star. So let's dive into the algorithm that makes customer segmentation possible. K means clustering. If clustering is the goal, K means is the method. K means is a simple but incredibly powerful algorithm for customer segmentation. Here is how it works. First, we define K, which is simply the number of tribes or clusters you want to find. If you have 10,000 customers, you might start by saying you want 5 major groups, means K is equals to 5. 5. Random centers, the algorithm places K random center points called centroids within your data. Third, the iteration. It then performs a simple two-step cycle repeatedly. First, every single data point, every customer runs to the nearest center. Second, the center point instantly moves to the true middle of its newly assigned customer group. Fourth, the convergence. This process repeats. Customer runs to the new centers, centers move, customers run again. It keeps iterating until the centers stop moving. At that point, your groups are perfectly optimized and you have your 5 distinct, well defined customer segments. The iterative process of drawing boundaries and moving centers is the secret to K means. It's what transforms raw purchase history into actionable customer segments. Why is all this important? It's the payoff. By using unsupervised learning and K means, companies can identify these hidden customer tribes or segments completely automatically. Instead of blasting out one email to a million people, they can send 5 targeted emails to 5 distinct groups. They save money on marketing, increase customer retention, and make their recommendations hyper personalized. Unsupervised learning is the quiet engine that makes modern businesses smarter by finding structure where we only see chaos.